Okay, so we just talked about operations with functions. We did adding, subtracting, multiplying, and dividing. There is another way to combine functions, and that way is composition of functions. So if you want to title your notes, Unit 1, we're still in Unit 1, composition of functions. So another way of combining functions is to form a composition of one another, of one with the other. So we'll talk about what that means today. If you need to pause throughout and write these down, I've already written the notes, but we don't have to wait on me to write. So it's written two different ways. They are synonymous with each other. This way is stated as f of g of x. So notice that our g of x function is inside the f of x function, or it can be written like this, where you read it as f is composed with g of x. So notice that this little circle means that it's a composition. Big thing that we're going to be working on soon next time is this is also a way to prove functions or inverses of one another. We haven't really talked about inverses yet, but this is a note for when we do talk about inverses next time. So here's a note for this. The domain of f composed with g is the set of all x's in the domain of g such that g of x is in the domain of f. If that's not confusing, I don't know what is, because that's pretty confusing to me and I'm teaching it to you. So don't worry, we're going to get into the nitty-gritty of how to do this. So pause right now and go through slides 1 through 4 of Desmos composition of functions. I'm going to pull it up here. Let me switch my sharing. Okay, so here's I can do this. Oh well, here's the first slide there. We'll be exploring composition. So I want you to just go through slides 1 through 4. Here's the second slide, evaluating. Practice these here. They're kind of like what they were on your test. And then here's the third slide. Explain what you did in terms of evaluating functions on the last two problems. This problem and this problem, you're actually practicing compositions already. It's just evaluating for you right now. And then do this last one. It's just a note. The notation, we already wrote this down. The notation used for compositions is that f composed with g of x or f of g of x. Notice that they mean the same thing, just you can write it two different ways. Then it talks about the range here. Mathematically speaking, the range, the y values of one function becomes the domain, the x values of the next function. So keep in mind that with the inverses that we're going to be talking about soon. All right, let's go back to our notes here. Make sure you fill in those blanks as you go. Here's our steps for composition. So let's say that we have two functions. One is f of x is 2x plus 4. And the second one is g of x equals 3x minus 1. So two linear functions here, right? Make sure you have a chance to write that down. Here's our steps for finding f of g of x. So that means that f is composed of g of x, right? So notice that g of x is being substituted for x. So notice that here it says f of x, but here we're finding when g of x is inside the x value of f of x. So here's our just two steps to find composition. We're going to substitute the inner function. Notice that the inner function is g of x here for the x values in the outer function f of x. So whatever's inside is going to be substituted for all of the x values for the outside function. So that means that this inside function g of x, 3x minus 1, is going to be substituted, plugged in, or evaluated, any one of those words will work, for the x value in f of x. And then you simplify, right? All right, flipping to the next page, let's go through the steps here. So just like I marked with my pencil, we're substituting that 3x minus 1 into the x value of 2x plus 4. And so here we have 2 times 3x minus 1 plus 4. We're going to distribute that 2 to 3x minus 1, and we get 6x minus 2 plus 4. Simplify by combining our like terms, and f of g of x equals 6x plus 2. Now let's look at it if we're flipping it around. Let's try g of f of x. So that means that we're going to substitute all of the function of f of x into the x values of g of x. So here's what that looks like. We're substituting the function of f of x, 2x plus 4, into the x value of 3x minus 1. We'll distribute again, so we have 6x plus 12 minus 1. And then we're going to simplify by combining our like terms here, 12 and negative 1. So g of f of x equals 6x plus 11. So here's another example, because sometimes when we get exponents here, it gets a little bit tricky, right? So here's our given, f of x equals 2x minus 3, and g of x equals x squared plus 1. So we're going to find g of x, and we're going to find f of g of x, and we're going to find g of f of x, just like we did in the last example. So pause the video, try this out on your own paper, and then come back and we'll do it together. So here's our example, f of g of x, that's the first one. That means we're going to take the function of g of x and plug it into the x value of 2x minus 3. Here's what that looks like. So we have 2 times x squared plus 1 minus 3. Distribute that 2. We have 2x squared plus 2 minus 3. Simplify by combining our like terms, positive 2 and negative 3. And our f of g of x equals 2x squared minus 1. So this one was a lot like the first two that we did together. This next one is a little bit different because it is substituting or evaluating the f of x function. And notice that our f of x is linear and our g of x is quadratic, right? So it gives us a little bit of a challenge. So when we evaluate g of f of x, we're substituting the function f of x, 2x minus 3, into the x value of g of x, which is x squared plus 1. So notice that the squared stays, right? But I'm just substituting 2x minus 3 into the x value. The plus 1 stays as well. So what does that mean? What does 2x minus 3 squared mean? It means we're multiplying binomials. Let me find my word. We're multiplying our binomial here, 2x minus 3, with itself, right? So we're squaring it. 2x minus 3 times 2x minus 3 plus 1. You can multiply this using the FOIL method or the box method, whatever is your choice. So when I multiply 2x times 2x, I get 4x squared. 2x times negative 3, we get negative 6x. Negative 3 times 2x is negative 6x. And negative 3 times negative 3 is positive 9. Notice that the 1 didn't change. I'm just moving it down as we go. Next step is combining our like terms, our negative 6 together and our 9 and our 1. And our final function is g of f of x equals 4x squared minus 12x plus 10. So notice that when we had a composition of two linear functions, both of those outputs were linear functions. When we had a composition of a linear function and a quadratic, both of these outputs are going to be quadratic. Interesting fact there. So now go ahead and complete the Desmos activity, pages 5 through 15. This will be your practice for composing functions.